This video is to help us understand how to simplify complex rational expressions, especially those that have bases raised to negative exponents. The first thing you want to do is take the numerator of the entire rational expression and rewrite that without a negative exponent. So we know that x to the negative 1 is the same as 1 over x. X to the negative 1 same as 1 over x plus 2. In the denominator, y to the negative 2 is the same as 1 over y squared. Therefore, when I'm looking at my fractions that I have in my numerator and the fractions that I have in the denominator, I notice that there is an x in the denominator right there, and there's a y squared in the denominator. We want to use those as our least common denominator. So I'm going to take my numerator of the rational expression and multiply by x, y squared. I'm going to take the denominator and multiply by x, y squared. Doing so will allow us to get a common denominator, will allow us to get rid of our fraction in the numerator. So what we now have is x times xy squared, which will be 1 over x times xy squared plus 2 times xy squared. In the denominator of xy times xy squared plus 1 over y squared times xy squared. This will help us reduce or eliminate our fractions in the numerator. These x's cancel, leaving us with y squared plus 2xy squared divided by, in the denominator, we're going to have x squared y cubed plus this y squared will cancel with this y squared, leaving us with just plus x. Once you are done with that and you now have your numerator simplified so that you do not have any negative exponents, you don't have any fractions, and you have your denominator simplified so there's no negative exponents and no fractions, you can take your numerator and factor it and take your denominator and factor. My numerator, both terms have a y squared in them. I'm going to factor out a y squared, and that leaves me with 1 plus 2x over, in my denominator, I can factor out an x times x y cubed plus 1. I can't reduce this, therefore we are done.